SQL, or structured query language, is a way for you to write intuitive questions or statements to pull and modify data within your relational database. A relational database table is like a single spreadsheet in Microsoft Excel or Google Sheets. The table is grid-like, and it stores data in a tabular format. It has columns across the top that define what is in each of these fields, and along the side, it has horizontal rows, each representing a single record in that table. One thing to note that is different from a regular spreadsheet is that each column will have a data type. So that column can only ever store one type of value, like a piece of text, or a number, or a date. Spreadsheets let you click on a column and click a button to let you convert all the values to display as money or dates, but a relational database will enforce rules that won't let you insert data into a field of the wrong data type. The design and layout of your tables is called the schema. A feature of a relational database is that multiple tables can relate to or link with each other. Think of this like having multiple sheets or tabs across the bottom of your spreadsheet. You might have a sheet, or in this case, a table, that stores all of the products that your business sells online. Another table might store your customers, and another table might store the orders. If I want to know who I'm shipping order number 1 to, then I would look at order number 1 in the order table, go across to the customer ID column, and take the number listed in this field, and then relate it to customer number 1 in my customers table. Now, let's look at how SQL statements can help you slice and dice this data. The most common data operations you will be performing against your relational database are create, read, update, and delete, which is shortened to CRUD. All of the keywords in SQL don't line up perfectly with this acronym, but to create new records, you will use an insert statement. To read data from your database, you will use a select statement. And then the last two CRUD operations do have keywords that line up. To update existing data in your database, you'll use an update statement. And finally, to delete any data, you'll use a delete statement. There are also SQL statements that allow you to create and modify the schema of your tables, such as create table or drop table for deleting an entire table. In this course, we're going to use some sample data that is preloaded for us, so we aren't going to edit the existing schema. But if you'd like to learn more about how to do this, then after this course, search our catalog for Create a Table in SQL. In this course, we're going to use the built-in SQL client that's included within the Azure SQL portal, and it doesn't overwhelm you with tons of features. But most of the larger SQL clients that you can connect to your database have the ability to change the schema of your database using a graphical user interface. These editors will write the SQL for you behind the scenes, so if you're just starting out with SQL, this is the easiest way to make changes to the design of your tables or add new ones. Check out my deep dive course on Azure SQL if you want to see how to connect this Azure Data Studio client to your Azure SQL database for making schema changes to your database. Now, if you want to edit your schema through SQL commands, keep in mind that those statements can differ slightly depending on which database management system you're using. So let's talk about the different database vendors. Several vendors make relational database management systems, or RDBMS, that are pieces of software that you install on your database servers that allow you to host and manage several databases. All of them have different costs and trade-offs. One of the most popular options is Microsoft SQL Server, which is what Azure SQL is based on. Azure SQL is one of the ways that you can run Microsoft SQL Server and host several SQL Server databases up in the cloud without having to do a lot of server management in an on-premise SQL Server install. In the cloud computing world, this is called Database as a Service. Other popular relational database management systems that you can host on your own servers on-premise or in the cloud are Oracle databases. MySQL started as a free and open source relational database management system and has been popular for running the database for web applications like WordPress. It was acquired by Oracle, and its code was forked into a new license as MariaDB. A lot of people also moved on to Postgres, or PostgreSQL, as another free and open source solution. SQL, the language, was standardized as an ISO standard, and most relational database management systems will just use standard SQL, also called ANSI SQL. The great thing is that the SQL that you will be learning in this course will work across almost any relational database management system with only slight modifications. Each vendor created their own extensions to SQL that extend the SQL standard. And as you get into the more complex features of each database, you'll start seeing the differences between these different flavors of SQL. SQL Server, which is what Azure SQL is using, uses a standard called Transact SQL, or T-SQL. Oracle uses one called PL-SQL. Once you get comfortable using SQL and start to understand the concepts in relational databases, switching between using different vendors and flavors of SQL becomes much easier. So let's set up our database and dive into some SQL. In your browser, go to https://azure.microsoft.com. In the upper right-hand corner, click on the sign-in link. To use Azure, you'll need a Microsoft account. You might already have one through your school or work that you could use, or you might have set one of these up when you first bought a new Windows computer. If you don't already have one, follow the prompts to create a new Microsoft account. After your account is created, you'll either be taken to the Azure portal or you'll click a button that says Go to the Azure portal. This is the Azure portal, and from here you can use any of the cloud services that are included within Microsoft Azure. From the Azure portal, type Free Services into the search bar at the top and click on the entry that auto-completes. Azure has a free tier that will allow us to use certain services for free if we keep our usage within some reasonable limits. Search this screen for the entry that says Azure SQL Database and verify the conditions of the current free offering as it applies to your account. We want to use Azure SQL Database, and they will let us create a 250 gigabyte database for free for the first year. Since we're just learning SQL, I won't go into what the S0 instance size means or what the 10 Microsoft Azure SQL Database transaction units means, but if you want to create your own database after this course and use it for production purposes, I highly recommend you check out my other course on a deep dive into Azure SQL to understand what these limitations are. You might be asked to enter a credit card number to create your Microsoft Azure SQL account, but if you keep your usage within the free tier and delete your resources when you are done, you shouldn't get charged. The offering may change over time, and in the next video, when we create an Azure SQL database, you'll need to make sure you select the correct size for your Azure SQL database to match the current free offering. Now, let's get started with creating a new Azure SQL database. From within the Microsoft Azure portal, in the search bar at the top of the portal, type in Azure SQL and click on the Azure SQL entry that auto-completes. This is the Microsoft Azure SQL dashboard, and it's where you'll create and manage your Azure SQL databases. Click the Create button at the top of the Azure SQL dashboard. Microsoft Azure gives you 3 different ways to deploy Microsoft SQL Server in the cloud. In my other course, Azure SQL Deep Dive, I'll get into the specifics of these other options, but the quickest way to get started is to select the Single Database option underneath the SQL Databases tile and click the Create button. This is going to create a cloud-hosted database that Microsoft manages for us, and we don't have to mess with installing SQL Server onto a server ourselves, or configuring backups, or keeping the server up to date with security patches. Under the Resource group, click the Create New link. For name, type Azure SQL Demo, and click the OK button. For database name, type Azure SQL Demo Database. Under the Server option, click Create New. For server name, type Azure SQL Demo Server. And since our server names need to be unique across all of Microsoft Azure, type some random numbers to the end of this server name. You'll see all of the check marks turn green in the pop-up if you created a unique and valid server name. For location, pick the region that's closest to you. Select Use SQL Authentication, and for the server admin login, type Azure SQL Demo Server Admin, and then set a password for your administration account. Then click the OK button. Next to the Compute and Storage option, click Configure Database. In the Service Tier pull-down, under DTU Based, select Standard. Make sure that the DTU slider is set to 10. Under the summary, it will say Standard S0 because that's the size of the server that we will get for free for 1 year under the free services tier with the 10 DTUs. Click Apply. And since this is only a demo, for backup storage redundancy, select the Locally Redundant Backup Storage option, which will keep our database within our region and not replicate it to other regions to keep it running if there was an outage. Once you are ready to go into production with your database and real users are going to use it, you can come back and change this later. At the bottom, click Next Networking. For the connectivity method, select Public Endpoint. And then click the Add Current Client IP Address setting to Yes. By default, no one can access your database from over the internet. This setting will add a firewall rule that allows your current IP address to access your database. If your IP address changes because your ISP randomly rotates your IP addresses, or you move to a different coffee shop and switch Wi-Fi networks, you'll need to add your new IP address into the network configuration of the server. At the bottom of this screen, click Next Security, and then click Next Additional Settings. For the Use Existing Data option, select Sample. If a message comes up letting you know that some of the options have changed, just click the OK button. This will create our new database with some sample data that we can use for learning SQL. At the bottom, click Next Tags, and then click Review and Create. You'll see a cost listed, but since this is a standard S0 server instance, it will fall into the free tier, and you shouldn't get charged as long as you delete this server instance within the first year of your account being open. Click the Create button at the bottom of this screen. It should take a few minutes for the new server and the new database to deploy. When it's done deploying, click on the Go to Resource button. In the breadcrumbs at the top of your Azure console, click on Home, and then click on Azure SQL from your recent items, or search for it in the Services search bar. You'll see that two resources have been created. One is a SQL server that is running our SQL database, which is the second resource that's listed here. Click on the SQL Server resource, which is labeled Azure SQL Demo Server with the random numbers that you appended to the name. On the left, scroll down to the Security heading and click on Networking. Under the Public Access tab, scroll down and look at the firewall rules. If your IP address changes and you can't connect to your database, click the Add Your Client IP Address button, and this will add a new rule with your IP, and then you can click Save at the bottom. On the previous blade on the far left, select your SQL database, which is labeled as Azure SQL Demo Database. On the left-hand toolbar, scroll to the top and select Query Editor. Type in the username and password you created earlier when we created this database. If your firewall rules are correctly configured, you'll be connected to your database. Now we're ready to start writing some SQL and taking our new database for a spin. But before we jump into writing some code, let's test your skills and make sure you know how to connect to your database now and in the future. Right now, access to our database is being restricted by IP address. Depending on which services you would like to access your Azure SQL database in the future, this is a quick and easy security precaution to protect your data from the public internet if only a few people will be accessing your data. But let's pretend that you would like to access your database from another location, such as a coffee shop. If you need an address to test with, use 172.26.128.50. Since it's a non-routable IP address and it's not going to open up your Azure database to any unwanted access. Add another IP address to your database and practice this new skill. You will want to edit the firewall settings on the Azure SQL server that your Azure SQL database is running on. To exit the query editor, you can select the SQL Server on the blade on the left, or click the home breadcrumb and find the server linked under your Recent tab, or you can click on the search and search for Azure SQL in the Azure console, and then click on the SQL Server listed. There's a lot of different ways to navigate around the Azure console, so feel free to use whatever method works best for you. After clicking on the name of the SQL Server, from the Details screen, scroll down and in the left-hand menu, underneath Security, click on Networking. If you don't know what your public IP address is, you can open a new tab and type into the Google search, "What is my IP address?" and it'll show you a card with your current public IP. Under the firewall rules, you can click the Add Firewall Rule button and add your public IP address. If you already have a rule for your public IP address from earlier in this course, you can use the sample IP I gave you. For rule name, you can put in anything, like from coffee shop. And then, for the to and from range, put in the example IP I gave you, 172.26.128.50. And then click the OK button. At the bottom, click Save to save this rule. If you really did move locations, you can also click the Add Your Client IP version 4 address button, because the Azure console already knows what your public IP address is. If you used the sample IP address that I just gave you, click the trash can icon to delete it. And then click Save at the bottom. Click the Home breadcrumb. Select Azure SQL from the recent items, and then click on the Azure SQL database that you created. Click on Query Editor and try your login again. If your network settings are correct, you'll be connected to your database, and we can now start writing some SQL queries. Return to the Query Editor and log into your database if you haven't done so already. The built-in Query Editor uses a similar interface to what you'll find in most SQL clients. On the left-hand side, it will list out the database objects that we have access to. In the main editor, you type in some SQL queries, and you'll see the results in the bottom pane. In the left pane, click on Tables. When we created the database, we selected the option to have Azure preload our database with some sample data. Our sample data is for a store that sells mountain bikes and accessories, so you'll see a product table for all the products our store sells. You'll also notice that we have a customer table and an address table to help us ship our orders. Let's look at how our store handles an order. Click on the arrow to the left of the Sales Order Header table to expand its list of columns. Now, click on the three dots to the right of the table name, and then click on Select Top 1000 Rows. In the Results tab in the Output pane, you'll see a result set that includes the first 1,000 orders. Click on the Messages tab. This will show you debugging output from the SQL Server, and here it's showing us that it returned 32 rows, so we only have 32 orders in our database. Click back to the Results tab. You'll see that this sample data didn't start at order number 1, but its first order is 71,774, and it seems to increment from there. If you scroll to the right, you can see the values in the other columns. The order record will store the customer ID for the customer who made this order. The Ship to Address ID will link to an address in our address table. The Total Due record will show how much the customer was charged for this order. Now, scroll up in the left-hand pane and click the arrow next to the Sales Order Detail table. Click the three dots to the right of the table name and click Select Top 1000 Rows. This will open this query in a new tab. Click the Run button to execute the query that's in this tab. This table is going to store a record for every product that was included within our order. For our first order, which is order ID 71,774, our very first online sale, a customer ordered two products, product ID 836 and product ID 822. The sales order detail table has two separate records, one for each product ordered. And all of them will have a value of 71,774 in the sales order ID column. That's how the database knows that these two products are included within this order. Scroll up again in the left-hand pane and look at the first 1,000 records in the product table. If you want to know which products are included in that order, scroll down in the query results until you find product ID 822. The query results might stop before you get to this value. Scroll to the middle of the results table and click on the Load More link. You might have to do this a few times to get down to product ID 822. If you look at the name of this product, you'll see that it's a yellow road frame. And to the right of the name, you'll see the product number. If you take a look at the product number column in the list of columns within this table, you'll see that it says in varchar and not null. Let's talk about what these properties on each of the columns mean and how the database organizes your data. In a relational database table, each column is assigned a data type. If you're familiar with using a spreadsheet, such as Excel or Google Sheets, you'll know that you can click on a column in your spreadsheet and tell Excel to set this column as a money column, or as a number column that rounds to decimal points. A relational database table works the same way. If you look at the list of columns in our product table, you'll see the data type listed next to it in parentheses. Cell start date stores a date time value only, so the only thing we can ever put into the cell start date column is a date and a time. Product category ID says int, which is short for integer, so we can only put a whole number into the product category ID column. No dates, no text, not even a number with a decimal point. Only whole numbers. But it can be configured to store signed numbers, so it can store negative whole value numbers. List price is a money data type, so it can only store numerical values representing money. Weight is a decimal data type, and this field is configured to store a numerical value that includes a decimal with a fixed precision of 2. So this weight field only allows you to have up to 2 values after the decimal point. You might be wondering why list price is a money data type, and not just a decimal data type with a precision of 2 for storing US currency. In the movie Office Space, the main characters try stealing money by collecting fractions of pennies caused by rounding operations when the database is doing calculations with money. Even the decision whether to use a money data type, which isn't available for all relational database engines, is a hotly debated topic online, with several pros and cons versus using a decimal data type with a higher precision of 4. Data types also help the database engine to sort and organize your data. When your database is small, you won't notice the difference between 2 different data types. But as your database grows in size, you'll see the database take longer and longer to return query results and consume larger amounts of disk space on the server. Slow query performance can make your entire store and business grind to a halt, and changing between data types later on after you've filled up your table with data is not always an easy task, depending on which data types you're converting from. There are a lot of data types you can use in relational database tables, but here's the most common ones you'll use in Azure SQL and Microsoft SQL Server. These data types also have similar names in other relational database engines, such as MySQL or Postgres. Int is short for integer, and it stores whole numbers. These are like t-shirt sizes, and you'll see variations of this data type in this size order: tiny int, small int, and big int. Smaller sizes process faster, whereas larger values can store larger numbers, but they take up more disk space and they're slower. Decimal stores numbers with a fixed number of places after the decimal point. Float stores floating point numbers, where there might be lots of numbers after the decimal point, and it's always in a different spot. Each has its own trade-offs based on what data you'll store in this field and what kind of calculations you'll do with this data. Char is usually a fixed length column in most database engines, so use this if you have data that'll only ever be a certain amount of bytes, such as a state or province abbreviation in a postal address. The more common field is varchar, which is short for variable character, and a varchar field can adjust its size within a certain range. Text data types are used for long paragraphs of text and store more than a varchar, but they aren't as efficient on space, and it can be harder for the database engine to search on these fields. Take a look at the product number and color columns in the product table. After the data type, it says null or not null. Not null is a rule that tells the database that every row must have a value in this field, whereas null says that a value is optional. For instance, a product always has to have a product number, but it doesn't have to have a color. The product ID column of the product table has a special flag next to it that says PK. This is short for primary key. Every row in your table needs to have some kind of unique key so that you can always reference a single row when you need to. If you scroll down in the results set of the product table, you'll see that you have 2 Sport 100 helmets. One is black and the other is red. the product numbers are different so that you can tell them apart even if they didn't have different names. But what if the manufacturer made a new version of the red helmet but gave it the same product number? Well, you could add a revision column so that you could tell these records apart. And in this case, your primary key, or your way of telling similar records apart, could be a combination of the product number and the revision number. But sometimes even that isn't unique enough. To make your database easy to work with, you need to have good data integrity. And you can do this by enforcing database integrity constraints. One of these constraints, or rules, is called entity integrity. And it means that every row in a relational table has to have some unique value as a way of telling it apart from the other rows. If you have 2 different red helmets in your product table, you need something to be able to tell them apart when you're looking at your table, even if the orders of the rows got shuffled around. The most common way this has been solved is to create an int column, set it as an identity column, and then the database will auto-increment a number every time a new row is added. You'll see this convention used in the sample data. The product ID is a primary key. The sales order ID is a primary key. The address ID is a primary key. Adding a new row to any of these tables will automatically generate a new ID for you by creating another ID in the sequence. And the next number in the sequence will be unique to that column. So all of the values in this column are said to have high cardinality. These database tables have a row GUID field using a special data type called unique identifier. Since hard drives have gotten larger and it's easier to store larger databases, most databases are now using the convention of having a unique column that stores a GUID, or globally unique identifier, which is a randomly created value that you can trust to be completely unique across all of your systems. Your GUID should be the only combination of this GUID that exists in the entire world. Collisions, or duplicates, are extremely rare. So if your company ever merges with another mountain bike retailer and you need to combine your products and orders together, both of your systems might have an order ID number 1, but their GUID values will be completely different from yours. Our sample tables are using this hybrid model where they are using integers for the primary keys, which makes SQL Server faster at sorting and linking tables together, but they also include the row GUID field that can be used as a fallback if you ever needed to merge this table with another similar table. In our modern day systems, where our data gets distributed between cloud providers and services and may get shared between multiple entities within an organization, a row GUID is a great way to uniquely identify a single row across all systems for all time. Trust me, you'll thank me later in several years for that little tip. In the result set for our product table, look at the values for the black and red helmets. Say that the manufacturer is going to send us a new green helmet. To add this to the product table, we will write a SQL statement that covers the first CRUD operation, which is C for create. To add rows to a table, we will use an insert statement. delete the query that the SQL editor put into this tab. Type insert into in all capital letters. You don't have to use capital letters in the keywords of SQL statements, but it's a common convention. And when you have a lot of SQL statements sitting together, it helps your eyes to see the different statements. Then type the table name you want to insert a row into. So type product, and you'll see the query editor autofill with the table owner and the full table name. Click on the autocomplete entry and then press enter. Inside a set of parentheses, include a comma-delimited list of the column names you want to insert values into. You don't have to insert data into all of the columns, but you need to insert a value into any column that is set to not null and doesn't have a default value set for that column. Modified date has a default value, and that will insert the current date and time, so we don't need to insert into that field. For the field list, type name, comma, product number, comma, standard cost, comma, list price, comma, cell start date. Then move to outside of the parentheses, press enter, and then type the keyword values in all capital letters, and then press enter again. Now we're going to provide a comma-delimited list of the values to insert into each column in the exact same order as the column names we just listed out. Since we are inserting into 5 columns, we need 5 values. Inside parentheses, type single quote, sport-100 helmet, comma, green, and then in that with a single quote, then comma for the next column. So the value for product number will be single quote, HL-U509-G, single quote, and then another comma. And then the value for standard cost is going to be single quote, 13.0863, and then single quote with another comma. For the field of list price, we're going to say single quote, 34.9900, single quote, then another comma, and then the value for cell start date. We'll do single quote, and then I'm just going to give it a date in the past. So I'm going to say the year is 2023-02-13, and then another single quote. And all that's inside parentheses. When you are passing in text or string values into a SQL statement, you'll want to surround each value with single quotes. Numbers don't have to be included inside of single quotes, but most database engines will cast or convert the string value into a number for you. When you finish typing your query, click the Run button. Click on the product table again, click on the 3 dots, and select the top 1,000 rows again. You can either scroll to the bottom of the results set by clicking the Show More link, or you can use the filter search and type helmet with a capital H. This will filter the result set to just the rows that include the word helmet, and you'll see our new record at the bottom of the result set. But keep in mind that this quick filter is case sensitive, so the H needs to be capitalized like in the sample records that we inserted. Before we move on to our next CRUD operation, we're first going to let you insert your own product into the product table. We just inserted a green helmet into our product table. You'll notice in our result set that the green helmet we inserted has a null or blank value for the color field. Imagine that the manufacturer has now made a purple helmet. Write a new insert statement to put this purple helmet into the product table. But this time, I want you to set the color field to purple. The product name will be the same as the last query, but just change green to purple. And the product number will be HL-U509-P, with the P indicating that it's a purple helmet. Click on the previous tab in the SQL editor to bring up our last query. In the column list on the second line, after product number, insert the column name color and follow it up with another comma. You could have put the color column anywhere within this comma delimited list, but I usually like to match the order of the columns with how they're stored within the table schema. But how you order the fields in the column list of your SQL statement doesn't matter, as long as you match that same order in the value list. So in the value list on line 4, I changed the value inside of the name field from green to purple. Then I changed the green product number from a -G to a -P. And finally, after this product number value, type in single quote purple, closing single quote, comma, and then click the Run button. Click on the next tab where the list of records in the product table is already open, and then click Run again. You'll see your purple helmet at the bottom of the product table with a new auto-incremented ID. And you will see that this product has a value of purple in the color field. Look at the result set for the new record that we inserted for the green helmet in the product table. If you wanted to just get the record for the green helmet, there's a much easier way than looking at the entire table and scrolling down to the bottom. And the filter tool we are using within the SQL editor is a feature of this query editor for filtering the result set. But there's a way we can have SQL do this filtering for us. If you have a value in the filter search, go ahead and delete it. When we open the top 1,000 rows of a table, the Azure SQL Query Editor is automatically building this select query for us. It starts with the keyword of select, and then uses the keyword of top to select the top 1,000 rows in the table. You could change this number and rerun the query to get a different number of rows. Then it says star, which means to pull all the columns from the product table. Let's change this query and remove the top 1,000. So now the query is going to get all of the rows of the database, not just the first 1,000. And then on the next line, type the keyword where in all capitals, and then type out the column name of product ID space equals, and then type the product ID of the green helmet, which is 1,000. click the Run button to execute this query. Our result set now only includes a single record, which is the green helmet. If your select statement had no where clause to it, it would return all the records. Most SQL query editors have the ability to only run queries that are highlighted by your cursor. Select the first line of this query and highlight it. Then click the Run button. The query editor only executed the query we had highlighted, so it ignored the where clause. Now extend your selection to the where clause and run it again. Depending on which query editor you select to use with your database, you need to check that it offers this functionality, but this is a great way to have multiple SQL queries in a tab and only execute them one at a time. Just be careful, because if nothing is highlighted, it will always execute all the queries listed in this tab, which can be dangerous later on when we start to update and delete data. Let's say you only want to get the name and the product number and not any of the other fields. Replace the star with name, comma, product number, and rerun your select query. This is useful when you are creating custom reports. And if you are writing custom applications to connect to your database, it's best practice to explicitly declare only the fields that you need in your result set. Querying extra fields that you're not going to do anything with will increase the network traffic between your database and your application, and as your application grows, it'll gobble up precious server resources, such as network bandwidth and RAM. Let's look at a few more ways we can slice and dice our data. Let's say you need to look up the green helmet by its product number. Change your where clause to say product number equals, and within single quotes, type HL-U509-G, ending single quote, in all capital letters, and hit run. When you are passing in a string of text, you want to surround it with single quotes. Also, if you don't match the case exactly as it's recorded in the field, like if you used a lowercase h instead of a capital H in the product number, the SQL Server engine in Azure SQL will still find this record. This might work differently in different database engines, but there are always ways to do case-sensitive and case-insensitive searches if you need that functionality. If you want to get all the helmets based on their product number, change the equal sign to the keyword like. And for the string inside of the single quotes, change the G to the % key and click Run. The % indicates a wildcard search, so it returns the row where the product number starts with the string HL-U509-. If you change this to HL % and run it again, you'll see that it now includes the black helmet, which was filtered out before because it doesn't have a second dash after the U509. You can search on multiple things at the same time. So on the next line, type the keyword and, name, like, and inside of single quotes, put %, black, %, and run the query. Now we are just getting the black helmet because it's matching on the product number and it searches for the word black anywhere in the product name, at the beginning, middle, or end. Change the query to remove the product number field as one of your selectors. So now your where clause is only going to say where name like black and click run. Now you are getting all of the products that have black in the product name. Hit enter, and on the next line, type or name like, and inside of single quotes, put %, red %. And now click run. Now the query results include any row where the name includes black or red. Now, change your where clause to where list price, and then use the greater than sign, and then say 20.00. And also, change the fields you're returning to name and list price by replacing product number in the field list with list price. Now run this query. You'll see in the results that it's returning any product where its price is greater than $20. It won't match on any products that are exactly $20 unless you change the operator from greater than to greater than and an equal sign. Now click run again and return the results for this new query. You can search for ranges within numerical columns, and you can also use these same operators to search for ranges within date-time columns. Just be sure to include any dates within single quotes, because you're passing in text, and the database engine will be able to parse a wide array of different date formats that you may be searching on. Let's sort this result set so we can see the products that are the closest to $20. Hit enter, and on the next line, type the keyword order by list price and click run. The result set now shows the cheapest products first and goes down to the most expensive. If you want to change the direction of the sort, add on the keyword DESC for descending after the column name of list price and run the query again. The first records in the result set all have a similar price, but let's also sort it by the product name, which will do an alphanumeric sort and show the larger bikes before the smaller bikes. At the end of the order by clause, add comma space name DESC for descending, and then click run. That's much better. If you want to keep your primary sort by price descending, but change the order of the secondary sort, change the descending keyword after the name column to ASC, which is short for ascending. Ascending is the default order, so if you don't specify anything, it'll be ascending order. You can also sort by fields that you aren't selecting. At the end of the order by, do a tertiary sort by weight by typing comma weight and then run the new query. You can't see that it's also sorting weight lowest to highest after the price and then the name because we didn't include weight in the select field list, but it is doing it regardless. Let's also pull in the product category. In the select column list, after name, type product category ID, and then delete the previous where and order by statements. In the result, the product category ID will be an integer, So you'll need to go to the product category lookup table and see what product category ID 18 is equal to. We can write a second query to do that real fast. Underneath your existing query, type select name from product category, and then click on the full table name that auto-completes. And then, without pressing enter, just type space where product category ID equals 18. You don't have to put different keywords of the SQL statements on new lines. The SQL engine doesn't really care about how you separate the keywords, as long as there is at least one space between them. But you'll sometimes see the keywords separated onto new lines, and that's only to make it easier for you to read. Highlight this new query and click Run. The result set is showing us that product category ID 18 is road frames. But wouldn't it be great if we could just combine all of this data into one result set? At the top, click the New Query button. To join these two tables together, let's start by referencing our product table again with a new select statement. One of the first issues we're going to run into with trying to combine these tables together is that if we want to display the product name and the category name, the column in both the product table and the product category table are both called name. You will get an error from your database engine if you try to write a select statement where both columns have the same name, because when you try to reference your result set, you'll have two columns with identical names and no way to distinguish between them. To get around this, I need to reference the column by its full name. So type select product and click on the product table that auto-completes, and then type period, and then in brackets, type name. The brackets around the table owner and the table name and the column name help tell the SQL engine that you are referencing database objects and not other functions or other things in SQL that might share a keyword with the name of your column. Then type space as, and then type product name. The as keyword creates an alias. So in your results set, instead of this column being labeled as name, it will now be labeled as product name. Then type comma, and on a new line or the same line, remember, it doesn't really matter, type product category, and then click on the full table that auto-completes, and then type dot, and then inside of brackets, name as category name. Then, on the next line, type from and type product, and click on the entry that auto-completes, which is your main table. Then, on a new line, type join, and type product category, and click on the autocomplete for the full table name. And then, next to it, either type space, or on a new line, type on, and then within parentheses, you're now going to tell the SQL engine how these two tables relate to each other. So type product, and autocomplete the table name, then type period, and in brackets, put in category ID, and then outside of the brackets, put equal sign, and then type product category and autocomplete its full table name, and then type dot, and then inside of the brackets, type product category ID. Now click Run on your completed query. If you use the left-hand pane to look at the columns in the table schema of the product and product category tables, you'll see that the field that links these two tables together is the shared value of the product category ID. Conceptualizing how tables link together is one of the most challenging parts of learning SQL. The statement we just wrote is using a join called an inner join. You can actually change the keyword of join to inner join and run the query, and it'll do the same thing. But there's also outer joins, such as left outer join and right outer join, and I would encourage you to dive deeper into these topics by searching our catalog for SQL join. Before we move on, let's give you a little bit of time to practice with your new query skills. The bike shop is wanting to run a sale on some of the oldest products in our store. They want to offer free shipping on this promotion, so they only want this sale to include items that cost $50 or more. And make sure the items in the report have a sell start date that is before January 31st, 2006. Management would like the report to only include the columns of name, product number, list price, and the sell start date. The first thing I'm going to do is write out the columns to be included in the final query. So for this query, that's going to be select space name, comma, product number, comma, list price, comma, sell start date. And I'm going to be selecting this from the product table. Sometimes when I'm first writing a query, I may include all fields in the select statement and use the star wildcard character. And then I'll check my results before I limit the query down to just the fields that I need. Then, for the first condition, to limit the results by list price, type out where list price is greater than or equal to 50. I used the greater than or equal to operator here so that if any products are exactly $50, they will still be included in the condition. Then, for the second condition, to limit the date range to any products sold before January 31st of 2006, type out and sell start date is less than, and then in single quotes, I'm going to put 1/31/2006. I used the less than operator so that January 31st itself won't be included in the search, but anything before that date will. I put the date in single quotes since I'm passing in a text string for the SQL engine to interpret. You can format the date itself a few different ways, and the engine will convert it internally. But if it gets the day and the month confused in your formatting, you can always pass in a string matching the ISO 8601 date format, which is 2006-01-31. If this last condition was harder for you, don't worry. I mentioned how to do a date search, but I didn't show it prior to this. As you work with SQL more, you'll start to develop a sense about how it functions and how it was designed. So when you start working with a new data type, you might try a few conditions on your own to see how it works before reading more of the documentation of your database vendor. Do you remember when we inserted a green helmet in our product table? When we put that record into the database, we didn't set a value for the color field, so that field is currently null for that record. Let's change that record and cover the U in CRUD, which is Update. Click the New Query button. Let's start by selecting the green helmet so that we can look at it before we update it. Type select star from, and then type product and let it autofill the full product table name. Then type where, name, like, and then in single quotes, let's put %, capital G green, and then closing %, and then run that query. If you scroll over in the query results, you'll see that the color column is blank, and that this field in our database is null for this row. To update it, in the query editor, hit enter twice, and let's work on this query in the same query tab. Type the keyword update, then the name of the table that you want to update. So in this case, I'll type product and click on the full table name that auto-completes. In SQL statements, you don't have to use the full table name, so you could just type product for the table name, but being specific and including the table owner prefix isn't a bad thing. Then, on the next line, type the keyword set, followed by the name of the column that you want to update. So type color, space equals, space, and then in single quotes, type green with a capital G. If you wanted to update several columns at once, you would just type a comma and then give it another field and value and so on. But for now, let's just update this one column. Then on a new line, type the keyword where. An update statement can take the same conditional clauses that a select statement can. If you don't include a where statement, it'll update every row in the table, just like a select statement without a where statement will select every row out of the database. We can copy the conditional from our select statement above since it only matches on the record that we want, but it's always safer when you want to update a single row to reference it by its primary key. So type product ID equals 1000, because in the query results from our earlier query, the product has a product ID of 1000. Highlight the update statement and click Run. Then highlight the original select statement above and click Run to view the new value for the color column. Now, let's look at how to remove something from the database. Let's now cover the D in CRUD, which is delete. And let's delete the green helmet product that we created earlier in this course. There's no easy way to undo a delete operation. If you unintentionally delete rows or an entire table, you will likely be restoring the entire database from a backup. And if this is a live database, that can be really tricky, since restoring from a point-in-time backup may mean that you lose data that was added or changed since the backup was taken. Because a delete statement, and sometimes even an update statement, can be so destructive, I usually write my delete statements first as a select statement, view the results, and verify these are the records I want to delete, and then change my select statement into a delete statement. Copy and paste the select statement we used previously to find the green helmet and paste it at the bottom of this query tab. Select just this new query and click the Run button. A delete statement uses a where clause just like the select and update statements, and can operate on one record at a time, like in our current query, or on several records, all matching your conditions. Since our query is only returning one result, and it is the green helmet, the quickest way to delete this record is to delete the select star line and just replace it with the keyword delete. And this would work fine, but I'm not going to run this. Even though the database is only returning one row, it's possible another user could be using this database if it was live, and they could be inserting a new product that does match this criteria. The safest way to delete a single record is to do what we did with our update statement and use a where condition to only delete this single record using the primary key, or something with a high cardinality like the row GUID field. So I'm going to change the where clause to where product ID equals 1000. And then I'm going to select my delete statement and double and triple check that I've selected the entire delete statement, including the where condition, and then click run. If you accidentally run your delete statement without the where line highlighted, it will just run the delete from product statement, which is a valid SQL statement, and it will delete every single row from the product table. Get in the habit now of taking update and delete statements seriously, and slow down and double check your work before you execute these statements. Now, it's okay for us to delete these products because we created them earlier in the course. But what would happen if you deleted the black helmet that was already in the database previously, or all the helmets from the product table? Well, we have orders that reference these product IDs in the order detail table. So in our case, if you actually had an order where someone had bought product ID 1000, the green helmet, then you'll have a value in the product ID column in the order detail table that links to a product ID 1000 that doesn't exist in your database anymore. Just like the database integrity constraint we discussed earlier called entity integrity, which says that every row needs to be uniquely identified with a primary key, there's another constraint we need to maintain called referential integrity. This rule says that we can't have ID numbers or foreign keys in our other tables pointing to primary key values that don't exist in our database anymore. So if we had orders referencing product ID 1000, the green helmet, we would first need to delete any references to this product first, which might include deleting the item from past orders or deleting entire orders. In the real world, you could maintain referential integrity by keeping the product in the products table, but set the sell end date to today to indicate you aren't selling this product anymore. Or you'll see a column that says is deleted or inactive, which is usually a bit data type, and it's one of the smallest data types because it can only store 1 or 0, and this field will be set to 1 to let the users of this database know that this column is inactive or was deleted. But this maintains referential integrity because other tables with historical data can still link to this record. So be careful with your updates and deletes and think through how this operation will affect other tables that link to this data. In this final challenge, I want you to update the list price on a set of products. The sales team has decided to run a sale on all of the bike helmets. Set the list price on all the helmets in the product table to $29.99. First, let's write a select statement so that we can see the current list price of all the helmets and make sure our conditional is correct before we make any changes to the database. I'm going to start a new query tab, and I'm going to type select star from product, the products table. And then for my conditional, I'm going to type where name like, and then I'm going to do a wildcard search for helmet. Your query results should only include the products that are described as helmets. Helmets are also listed in the database as a product category, so bonus points if you joined in the product category table and selected out the records this way. That query would look something like this. We didn't give the test records that we previously inserted a product category, so it will be missing from this list, but you can always use one of the other methods to select it out if you want. But since a helmet has the word helmet in the name, searching the name field of the product table works just as well. To write the update statement to change the prices, type update product for the products table, set. The field is going to be list price equals 29.99. Keep in mind, if you run this query as it is, it will update every product in the table to $29.99, so be careful. For the where statement, you can just search for product ID equals 707 and then just update each record in sequence because there isn't that many of them. You could also use an OR statement and list out each product ID to do this operation in one query. If you went about it this way, here's a shortcut that you can use. You can use the keyword in, and in parentheses, pass in a comma delimited list of all the IDs you want to update. And you could also just write your conditional as where name like helmet, since that's the same one that you used in your select statement. That works just as well. And you could also just write your conditional as where name like helmet, since that's the same one you might have used in your select statement. Just keep in mind, you aren't referencing the rows by a high cardinality value, so it could update rows someone else is adding or changing. Let's make sure we clean up our test environment so that we aren't charged anything once the free plan runs out. In the Azure SQL console, click on the Home breadcrumb. Click on the Azure SQL recent item or search for it in the Services search bar. Click on both the database and the database server, and then click the Delete button. Type Yes in the box to confirm, and then click on the Delete button. It might take a little bit for Azure to finish deleting the resources. If you want to dive further into learning SQL, the language for data analysis, then search our catalog for learning paths on SQL, and you can learn more about joins and designing data schemas and doing more complex programming with Microsoft SQL Server, which you can use within Azure SQL. If you want to dive further into Azure SQL itself and explore how to administer it within Microsoft Azure, search the catalog for my deep dive course on Azure SQL. Thanks for spending this time with me and learning a bit about Azure SQL, and I'm excited to hear about all of the neat things you're going to do with your new query superpowers.